All right, folks, we're back with another example from your Chapter 14 practice test. This example says that we have a couple of arcs we got to find. It's the same ones as before, the measure of arc PQ and the measure of arc QR, and we know those two things are the same. And again, PQ is right here, and QR is this arc here, and we know that those two things are the same. And then they give us a different angle now. We know that the measure of angle PSQ is C. PSQ is this angle right here, and if we notice that that angle, that vertex, is outside of the circle. So that means that this angle C, whatever this is equal to the difference, the average difference of the intercepted arcs. So what that means is that this angle C is equal to this arc right here, so this red arc, because that's being kind of intercepted by the two angles, or the two rays, I'm sorry, and this green arc, these are kind of the two arcs that this angle outside of the circle has separated the circle into. So this angle C is going to be equal the red arc minus the green arc divided by 2. That's how big angle C is. And we're taking the difference because the angle, the vertex of the angle, is outside of the circle. So the red minus the green has to be divided by 2, has to be equal to C. So this is kind of what we're getting at here. We have arc P, R, Q, this arc right here, minus arc PQ divided by 2 equals C. This formula comes from the fact that this is the angle measure of an angle that is outside of a circle. So the angle right here is clearly outside the circle. This angle measure has to be equal to the difference of the two intercepted arcs, which I have highlighted here, divided by 2. But we want to find PQ and QR in terms of C. So we kind of have this PRQ here that we don't really need. We don't need it all because we want to find out what PQ is. We want to say PQ is equal to what with respect to C. So we want to have a PQ on one side, isolate PQ, get C on the other side with no uncertain terms there as well. So we kind of have to get rid of this PRQ because we don't want PRQ in our answer. We just want to know what PQ is. And if we find PQ, we will also know QR because those two things are the same. So I have to eliminate this PRQ. That needs to go. I need to substitute that with a PQ ideally because we want to find out what PQ is. Well, we also know if we look at the picture that the entire circle is accounted for here. We have P, R, Q, and then we have Q back to P. So the entire circle is accounted for. So if I take the red arc and the green arc, and if I add them together, I'm going to get 360 because they're 360 degrees in a circle. So we know that arc PQ plus arc PRQ is equal to 360 because the entire circle is accounted for here. So let's solve this for PRQ. What I mean by that, I mean let's subtract PQ on both sides, because if PQ plus PRQ is equal to 360, then PRQ is equal to 360 minus PQ. So this is what PRQ is equivalent to. So why is that beneficial? Because now I can take this value of PRQ and substitute it into this equation, so I just have arcs PQ in there. So what does that look like? That looks like this. So now notice these two equations right here are actually the exact same equations. There's nothing different about these two in terms of what they're equivalent to, because I've replaced PRQ with 360 minus PQ. That's all that's happening here. It's exactly the same thing. Only I have 360 minus PQ instead of PRQ, because PRQ is equal to 360 minus arc PQ. So these two are the same. Now what's nice about this is I have just PQ in the equation, arc PQ, because that's what I want to find. And then I have a C in there. So now I have everything that I need. I just have to do some simplification to find out what the value of arc PQ is with respect to C, or in terms of C. So let's do some algebra at this point. I have negative PQ minus PQ. that is negative 2 PQ, because these are like terms, and if you have negative 1 minus 1, you have negative 2. So just combine these terms to get negative 2 PQ. And then I have 2 terms in the numerator, a 2 in the denominator. I can do some simplification there, divide both terms in the numerator by the denominator, and then I get 180 minus 1 PQ, because these canceled out, and the 180 comes from 360 divided by 2, that equals C. Almost done. Not quite, but I'm almost done because I want to solve for PQ. Now notice I have a negative PQ here. I don't like that. So what I'm going to do, and there's a couple different ways you can do this, but what I'm going to do to get rid of that minus PQ is I'm just going to add PQ to both sides. Now I have a positive PQ, which is good because I want to know what positive PQ is. I want to solve for the positive variable. And then I have this plus C here. There's a positive C. But if I want to solve for PQ, I'm just going to have to subtract C on both sides. So then I get 180 minus C equals arc PQ. So that means that minor arcs PQ and QR in terms of C is 180 minus C. And since I've solved for PQ, this green arc here, I have also solved for QR because those two things are exactly the same.